Hello geometry class, this is your remote lesson for in Unit 6 Lesson 10. We're doing parallel lines in the plane. You either need to have printed out the handout or you'll have binder paper, and you're definitely going to need some graph paper today because you will be graphing some lines, and it's best if you have graph paper to do that. So if you don't have graph paper at home, use a ruler and to make sure that you can make a grid that is equally spaced so that you know when you're graphing you're getting an accurate depiction of the graph. Okay, so remember to put your name and date on the paper, and in this problem it says to just draw any non-vertical line. So I drew a line. You could draw it anywhere you want. This is where I chose to draw it. So I have this line, I labeled it as number 1, and I'm going to take that line, and it says to draw two possible translations. They could be anything, but a translation just means to move it either left or right or up or down or some combination of those two. So we're not stretching and shrinking or rotating this at all. We're just kind of shoving it somewhere. So I'm going to move it up 5 units, and when I do that, it gets up there to where it's blue. That's my second line. And the other translation is I'm going to move it down 3 units and to the right 2 units. And there you have it in red. And so I'm showing you even in the diagram that this one went up 5 units, went here, and then this one here, I took this 1 point, went down 3 and over 2, and it's right here, and then the line got moved over there. And it says find the slopes of each one of those. If we look at this, it kind of looks like they're the same slope, but we need to double check. And so we look at the slope, the rise and the run. The slope of line 1 is 1/2. The slope of line 2 is 1/2 still, and the slope of line 3 is also 1/2. So all 3 of these lines do in fact have the same slope. And I did that by just counting, going up a rise over run, and I went up 2 and over 4, so that reduced to 1/2. Okay, on this next problem we've got Priya. And Priya has made a proof. She's written this out, and we're supposed to double check it. So I'm going to read it, and as I read it, I'm going to mark the diagram, which is what you should be doing, is marking your diagram as we are reading what she is doing here. So I haven't gone on to the questions yet. I'm just going to read her proof and mark the diagram according to what she has written here. So it says, consider any 2 parallel lines. Oh, they're parallel lines. So I need to call them something, so I call them L and M. And they're parallel. It says, assume they are not horizontal and vertical. So these 2 lines, they're random. They are parallel. That's important. And they're neither vertical, straight up and down, nor are they horizontal. They're not lying down flat, okay? So they're just 2 random lines that are drawn here. They could have been drawn at any angle, but this is the angle that she chose to draw when she put them in her diagram. I need to mark that they are parallel, so there I have them marked as parallel. And then it says, therefore, they must pass through the x-axis as well as the y-axis. Well, we can see that both of them do cross the y-axis, both of them do cross the x-axis, and that has to be true because they are neither horizontal nor vertical. So they're going to have to cross the horizontal and vertical lines. It says, I mark that they are parallel. I just want to make sure we're marking that they are parallel. And it says it forms 2 right angles with the second congruent angle. And so what are we talking about? It forms 2 right triangles. So here's a triangle, and this triangle has a right angle right here because it's the axis. And this is a right triangle. So we're talking about these 2 triangles that are right in here. And we notice before we even move on to the triangle business, I've marked, and she had marked with a little red, I marked them more in yellow so you'd see them, these 2 angles, which are vertical angles, and they're congruent, and these 2 angles, which are vertical angles, and they're congruent. And before I go any further, because I'm always analyzing everything she's talking about, everything in the diagram, I notice that this group of 2 angles that are marked yellow, and this 2, they're all congruent. And why do I know that? Because I've got 2 parallel lines, L and K, both of them cut by this transversal X. And I could talk about this angle right in here, and this one right down here, that those are alternate interior angles, and therefore they must be congruent. So I've got alternate interior angles are congruent. Now let's look at those two triangles. Well, there I made them a little darker so you can see here's the two triangles. And both these triangles have a right angle right here at the origin of the axes. And we've already determined that this angle in here is congruent to this angle in the other triangle because of alternate interior angles. Priya names that angle theta. So I went ahead and marked it in the diagram as theta. And then it says the tangent of theta. Tangent of theta. Tangent happens to be the opposite over the adjacent. So I need to label these something. So I'm going to label the legs of that larger right triangle as y and x, as you see in the diagram. So you should have that on your paper. And tangent of this angle is going to be y divided by x. In this little triangle, I'm going to label them a's and b's, and opposite theta is b. So the tangent of the theta here is b over a. But since both of these angles are the same, they're both equal in measure, the ratio, whatever the number is, 3 to 4 or 6 to 8, they have to reduce to the same amount. We know that y divided by x has to be the same thing as b divided by a. Why do we have to know this? Why do we know that this ratio is the same? Well, because that's the tangent. Tangent of theta is y over x, and tangent of theta is also b over a, but it's the same theta, so it's the same tangent, so these have to be equal in measure. Now, there's another reason we know that has to be true, because these two triangles, these two right triangles, I have a right angle and theta, and in this one I have a right angle and theta. So by angle-angle similarity, these two triangles are similar, and therefore any corresponding parts, so if I compared this leg to this one, has to be equal to the ratio of this corresponding, because the y and the b correspond, and x and a correspond. Now there's something else that's really important about this y divided by x, and if we look at that in relationship to the line, so I'm still just thinking about what Priya is talking here. Line L happens to have a rise and a run. Y is its rise. That's how far it went up from this point here to this point. It rose y and it ran x. So this is rise over run, which is the slope of line L. So I put that as m sub L, meaning the slope of line L. And that's what that is. And b over a, well, from this point right here, this is the rise and this is the run. So the rise and the run of this line is b divided by a, meaning this right here is the slope of line K. So I have here slope of line K. If these two are equal, because these are the tangents and they are equal, then their slopes are equal. So by saying that they're parallel, we know their slopes are equal, and we've just proved it. Now let's look at the questions that go along with this problem. So the first question says, how does Priya know that the right triangles have a second congruent angle? Meaning, how does she know that theta, right here, is congruent to this theta? Well, we've already done that because we examined it before we looked at the questions. And we know those two angles are equal because of alternate interior angles are congruent between two parallel lines. So I just say there it is. That's why I know it. Okay? Now let's look at question number 2. I don't have enough room to write it here, so I went on another page. Same diagram that we started with, but now the markings aren't there, so let's get all those markings back in it. You have it on your paper already. So here they all are, same as they were before. And I'm going to write down what we just wrote about the ratios. So y divided by x is equal to b divided by a, meaning the slopes are equal, which is also the stating that they are parallel. It says, show or explain what is meant by the tangent theta equal in both triangles. Well, here we have it. We did it. We already did it before we even looked at the questions because we examined the problem. And I'm going to say here what we were talking about. Since the triangles are similar by angle-angle triangle similarity, the corresponding parts are proportional But what does proportional mean? It means their ratios are equal. And that's what this statement is right here. Their ratios are equal. Because they are similar, corresponding parts are proportional, so therefore their ratios must be equal. And the third question with this one is, how does this prove the slopes of parallel lines are equal? I want you to remember that these two lines were two random parallel lines, okay? And we were able to take these two parallel lines, do all this, and prove right here slopes were of equal measure. So since tangent theta is the ratio of the vertical to the horizontal, meaning we've got this, the y over x and the b over a, since this is the tangent of thetas and the tangents are equal, that's tangent is also known as slope. So we prove that since the tangents were equal, then the slopes must be equal. Now let's look at this next problem. Next problem is we're going to do something with a parallelogram. So we start off with this equation, y equals 2x plus 3, which means we have a slope of 2. And it says passing through the point negative 4, 1 is another line. So we have still a slope of 2 and the point negative 4, 1. Same slope because we wanted parallel lines. And this is write the equation of that. Well, we learned in our previous lesson that if you've got the slope and you have a point, we can use the point slope form of a line, which would be y minus the y, so y minus 1, equals the slope 2 times x minus the x value there, which is negative 4. So this technically is it. We're done, except that we should simplify it. So we shouldn't write this as minus a negative. That's going to become plus 4. And then I distributed the 2, so we got 2x plus 8. And lastly, I'm going to add 1. So we didn't do this on the other lesson, but I'm going to do that. I'm going to solve for y. And I have it in this format, y equals 2x plus 9. This is a format you are maybe more comfortable with. This is the y equals slope-intercept form of a line. It says to graph. This is why you need graph paper. You've got to graph these two lines. Graph the line y equals 2x plus 9 and the line 2x plus 3. So there I have it. I graphed them on a piece of graph paper, and we were told about it passing through the point negative 4, 1. So that's where I started the transformation one. So this is the original. This is y equals 2x plus 3. And this is the parallel line that goes to the point negative 4, 1. I happen to make it as a translation. You can see that we took this line, and really all we did is we moved it over 3 units. They're parallel because in the equations they have the same slope of 2. And I'm going to connect them. It said connect to make a parallelogram. I did an easy connection where I just drew this is actually the pre-image. So I took from that point, drew a horizontally over, and I did the same thing here, horizontally over. Since these are both horizontal, and we moved them both 3, we can see that this is a translation, 3 units to the left. And since it's a translation, then those lines have to be parallel. But we already knew that because in the equation they had the same slope. The segments that connected them, they're both horizontal. Well, horizontal lines have a slope of 0, which means they're parallel since they have the same slope. And since both pair of opposite sides, both pair of opposite sides are parallel, these two are parallel, and these two are parallel, then by definition, the quadrilateral is a parallelogram by definition. And we are done with the proof that this created a parallelogram.